So I'd like to spend a little bit of time talking about Chapter 8's key concept 8.4, which is dealing with three possibilities for specifications. So remember, a specification is which variables are included in a regression. So the the writing here is coming out atrociously. Let me write it down here. Specification, right, is what the specific equation looks like for running our regression. And we often have a variety of specifications that we consider. And here are three that include interaction terms. So an interaction term is when we have two variables that are multiplied by each other. We have, in this case, a continuous variable x and a binary variable, a dummy variable, an indicator variable d. And there are three possibilities for these. So we can have the each variable entered alone, so they would have different intercepts and the same slope. So beta 1 would be the slope for both of the groups defined by d. Remember, the dummy variable d defines two groups, the zeros and the ones. The intercept would be beta 0 for group 0 and beta 0 plus beta 2 for group 1. So that would be the first case. The second case is different intercepts and slopes. So here we have the intercept defined by beta 2, the difference in the intercept. So the intercept is beta 0 for group 0 and beta 0 plus beta 2 for group 1. The slope is beta 1 for group 0 and beta 1 plus beta 3 for group 1. And then we have a third case, the same intercept but with different slopes. And we would almost never do this in practice. We'd always prefer the more general specification, but just for completeness we have the case where the intercept is beta 0 for both groups, but the slopes are different. The slope for group 0, defined by d equals 0, is beta 1, and the slope for group d equals 1 is beta 1 plus beta 2. We can look at graphical representation of these three different possibilities. That third possibility is down here in figure 8.8. We have the same intercept but different slopes, right? So the slope for group d equals 0 is beta 1, and the slope for group d equals 1 is beta 1 plus beta 2. Now, this could obviously, if beta 2 were negative, this slope would be underneath the first slope, right? So all depends on the sign of beta 2 and the sign of beta 1, right? So we could have the two slopes looking like this. So this is a generic. It doesn't mean that the slopes are always positive. It just means that the slopes are different. And it's certainly possible for us to have one group slope going this way and the other group slope going the other way. So all those possibilities are there. We're not excluding them. Just for illustrative purposes, they're drawing positive slopes with positive coefficients. Our second case there was different intercepts and different slopes. So here we see the different intercepts, and then the slope here is beta 1, the slope here is beta 1 plus beta 3. So they have different intercepts and different slopes. And in our first case that we saw when we did multivariate regression, we have same slopes but different intercepts. So there the dummy variable is the difference between group 1 and group 2 on average, and they have the same slope. So that's the difference between them on average. So that's how we interpret these various interaction term specifications.